There are real-world situations that can be modeled by quadratic equations. And when you have one of those quadratic equations, each of these terms represents something different in that real-world situation. So today we're going to look at what each term in a quadratic equation represents in a real-world situation. So the function notation that you're given will typically tell you what is being compared here. So h of t is going to be used to compare the height of an object in terms of the time that object's been in motion. The second thing that we have is the first term here, this negative 16t squared. Now, this is our quadratic equation. It's in standard form, and the fact that we're using t's instead of x's isn't a problem. The t just represents time. Okay, this negative 16, though, represents our force of gravity. Okay, so our first term, our a value, is always going to represent our force of gravity. The middle term, the b term, is going to represent the initial upward velocity. That's a fancy word for speed. So this is our force of gravity. This is the initial speed of the object. And the last number that we have in our equation represents the height that the object started at, its initial height. So we've got our gravity, our starting speed, and our starting height. Now, one thing that I forgot to mention, when you look at your gravity, I want you to notice this is a negative number. That makes sense because gravity pulls down on an object. Now, these three terms are always going to have the same representation. Always gravity first, then speed, then height. And an easy way to remember that, if you think about these words, gravity, speed, and height, they kind of look like the word gosh. Okay, so think of the word gosh and you'll get those in the right order. So here's a real world situation that has a parabola, and we can see it's modeled by this picture right here. If we graphed it, we've got our time and our height in feet. So this little guy is throwing a water balloon off the balcony. The height of that water balloon is modeled by this equation. So the height of the balloon compared to the time is equal to negative 5t squared plus 20t plus 60. What we need you to be able to do is answer questions like, what represents the force of gravity on the water balloon? Now remember, gravity is this first term. So our gravity is going to be represented by, negative 5. Not the t squared, that's our time. Remember, t stands for time. So when we're talking about the force of gravity, we just want that number. What is our initial speed? Well, that's the middle term here. So we would say our initial speed is 20. And what's the initial height of the water balloon? Remember, that's our starting height. That's our last term here. That's going to be 60. Now, we're going to look at another situation. It's very similar, but it's got a little bit of a difference here. So in this case, Delaney is hitting a golf ball, and the golf ball's height can be described by the equation negative 8t squared plus 98t. Okay, so again, what's the force of gravity? We're going to look at this. Our first term, our force of gravity, is going to be negative 8. What's the initial speed? Okay, that's our middle term. Well, in this case, our second term, which is going to be 98. Now, here's where this problem's a little different. What's the initial height of the golf ball? Well, that would be right here. Okay, there's nothing here, and I want you to think about what that means. Okay, if there's nothing there, it means we have a plus 0. Okay, but mathematically, that's like an invisible thing. We don't have to write it. So if it's not there, you have to know in your head it means plus 0. And why is it plus 0? Why is our initial height plus 0? Well, think about it. This golf ball is on the ground. And if the golf ball's on the ground, it means its starting height is 0 because it's 0 feet off the ground. One more situation to look at. In this case, we have a dolphin that's jumping out of the water. Okay, we have his equation right here, negative 16t squared plus 64t minus 10. Our force of gravity is that first term, negative 16. Our initial speed is that middle term, positive 64. And our initial height is going to be this last term, negative 10. Now, the reason I wanted to bring this one to your attention is, why is this height a negative 10? What does that mean in terms of our dolphin? his starting height is -10. What that means is the dolphin started his jump underwater. Okay, he had to get up speed from down here underwater before he starts his jump, before he breaks the surface. So that's why his initial height is -10. So remember, when you look at an equation, gravity first, then speed, then height.